In the last class, we talked about mode, median, and mean. There are a few other statistical measures that we're going to be familiar with. Okay, the first one is the range. The range is the difference between the largest and the smallest value. So if you think back to our last lesson and we listed them from least to greatest, you could see what the range is. You would look at the least to greatest values and just see how far apart they are. Okay, another term is something called an outlier. It's a value that is much smaller or larger than the other data values. Okay, sometimes there are no outliers, but usually an outlier just doesn't seem to make sense, and maybe it was not a real legitimate statistic. Okay, and a trimmed mean is a calculation of the mean found by removing the highest and lowest values. In other words, getting rid of these outliers. Okay, it's supposed to make the mean a little bit more accurate. Okay, so let's take a look at some examples here. So the table shows NHL point leaders for 2 seasons. Okay, we've got this season right here, and then this one right here. Okay, so it says determine the range, the mode, the median, and mean of the data for each season. Okay, I think you should be able to do that. But I'll do the first one with you, and then you try to do the second one. So the range, if we look at the highest value, take away the lowest value, you're going to end up with 99 is the range. Hey, that's weird. Gretzky's first, and it's 99. That was his number. Okay, the mode. Well, do you see any number repeating itself here? No, I do not. So we're going to say there is no mode. There's nothing that repeats itself more than another number. They're just all one time. Okay, the median will be the middle number if we cancel off the top and the bottom, and then the next two, and then the next two. It looks like the median is 131. Okay, and the mean, if we add them all up and divide by 7, the mean turns out to be 140.8. All right, you guys try the next one. Okay, so pause for a second and then see if you can do this. All right, so the range would be 104 take away 85, which is 19. So you can see there's not nearly as big a gap between the highest and the lowest. The mode, does any number occur more than another one? Nope. The middle number will be 94. And the mean, if I add them all up and divide by 7, it will be 93.8. Okay? So which data value appears to be an outlier in one of the 2 seasons? Explain what might have caused the outlier. Okay. Take a look at these numbers. Do you think there's an outlier? Well, a sort of a gimme or an obvious clue to there being an outlier is when the range is really big. Okay? If you look at the range for 2010, it's small. All of these numbers kind of cluster pretty close together. Okay? If you look over here, though, there's one number that doesn't seem to fit. That's the 215. Okay? In 1985-86, the value of 215 is an outlier. Okay? In fact, it's 74 points more than the next one. Or maybe I'll just say higher. 74 points higher than any other number. Okay? And why do you think this is? Well, in this case, Gretzky was just so much better than everybody else. We'll use a real fancy word here. He was a phenomenon. Okay, even today, most of his records stand, and they're so far removed from anybody else's that we're never going to get there. I mean, right now they talk about 50 goals in an NHL season being fantastic. Well, Gretzky had 92 in 1 year. No one's ever going to score that again. Okay? Now let's remove the highest and lowest for each season and find the trimmed mean. Okay? So let's do 1985 first. So if we take away the highest, so 986 is the total. If we take away the 215 and we take away the lowest one, which was 116, all right, then we end up with a mean. This is a new number now. It's going to be 655 divided by 5, and you end up with 131. Let's go and look if that's any different than what it was. Well, you can see that the mean originally was 140. Okay, so that's changed quite a bit. Let's look at the other example. If we go to 2010. So in this case, if we take away the total, the 657, that was the total of all of the 7, take away the highest point total and the lowest point total, then your new mean would be 468 divided by 5, and this is 93.6. And if you look at that, that's really no different. Okay, so this is why sometimes we want to trim the data to find the average. We want to get rid of those outliers that don't really make sense when you're considering the average. Okay, does removing the highest and lowest values affect the mode and the median? No. Okay, the mode and median will still be the same. All right, and should the outlier be removed? Explain. I guess it depends the purpose that you're trying to look at for the average. Okay, if you want to show, for example, if you want to show that the league is scoring lots of goals, it might be beneficial to leave somebody who's scoring lots of goals in. Okay, but if you're just trying to compare 1 year to the other year, then having one exceptional player doesn't really teach you what the similarities or differences are. So I think it really depends on what you're trying to say or what you're trying to figure out. Okay, so we'll maybe make a few little notes here. Gretzky's score shows his impact on the league. If you want to show his impact, leave it in. This shows scoring is up when he plays. Okay, that's just an example. You could probably think of other answers too. That's just one. Okay? Next, let's talk about percentiles. A percentile rank is a number between 0 and 100 that shows the percent of data at or below this number. For example, the median is the 50th percentile. This is what you would call the middle. Half would be above, half would be below. But we don't always have to talk about the 50th percentile. We may want to talk about, the top 10% or something like that. Okay, so let's look at this example here. The players on a senior boys volleyball team have the following heights. Lists a whole bunch of heights there. Write the numbers in order from lowest to highest. All right, I think 143 is the shortest. Okay, then I think we got 155. What comes next? 162. Okay, then 165, then 167. Okay, next we'll have 172, 175, 178, 182, 187, and 190. So there they are, highest to lowest. Calculate the percentile rank of the players that are between 172 and 190. So we're looking for what percent of the players is that. Well, you're going to see there are 5 numbers that are not included in that, 6 in the other, so we're close to 50%, but let's actually calculate it. Okay? So there are 5 numbers below 172. Okay? The number of raw scores, there's 11 total scores. So the percentile rank would be 5 out of 11 times 100. Okay, so this is equal to 45 percentile. Okay? So that means that 172 is at the 45th percentile. Okay, let's look at 190. So scores below, there are 10 scores below out of 11. So this would be 10 out of 11. So 190 is the 91st percentile. Okay, instead of percent like that, we'll write 45th. Okay, so what does this mean? Well, if someone said your test score was in the 90th percentile, this tells you that 90% of the marks were below yours, 10% might have been above yours. Okay, now that's not totally accurate because 190 was our highest number, and it says here that's the 91st percentile. Okay, so let's try this one. Calculate the percentile rank for the number 8. Okay, so they're in order already. So how do you do this? How do you find the percentile rank for 8? Okay, well, it's the number. If you look at the formula here, maybe this should go in your cheat sheet. It's the number of scores below 8, 1, out of, how many scores are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10 times 100. So this is 10th percentile. Okay? All right, next one. Tom and Jerry have just completed the mortgage brokerage in BC course. In order to become mortgage brokers, there were 175 people in the course. If 90 of the students ranked lower than Tom in the course, what was his percentile rank? Okay, his percentile rank will be how many students were below him? 90 out of 175, and then times 100. Okay, so he is in the 51st percentile. Pretty close to average. Okay, calculate how many people scored lower than Jerry. There were 50 people that scored higher, plus 3 that scored the same, plus Jerry himself. Subtract these numbers from the total. So again, we want percentile. Okay, so there were 175 people, and I'm going to take away 50. Okay, they scored higher. So remember, we're looking for who scored lower here. So take away the 50, take away the 3 that scored the same as him, plus take away himself, and this gives you 121 scores. So there are 121 that scored lower than him out of 175. Okay, so that means he finished in the 69th percentile. Okay, Tom's percentile rank of 51 and Jerry's of 69 mean that Jerry did better than Tom. But that is all that you can say about their comparative scores. It is possible that their grades differed by very little or by a lot. The percentile ranking does not give you this information. Okay, All we can say about their test scores is that Jerry scored higher, right? The reality is that Tom was 51. There may have been, he may have had, let's just make up a mark, he may have had a mark of 80. There may have been a whole bunch of people that had a mark of 81, and Jerry might have had 82. Okay, we don't know how far apart they are. We don't know how much better one did than the other. Okay, we just know in the context of the 175 that were in there. All right. Example 3. John participated in a survey of people's wages in his town. He learned that his wage was in the 70th percentile, and 180 people were surveyed. How many people surveyed earn less than John? Well, remember what our percentile formula is here. It's the number that are lower, okay, over the total number, and then we're going to multiply that by 100. Okay, well, we know the percentile is 70. All right, we don't know how many are lower. We know there's 180 people. Okay, so we need to figure this out. How do I figure out this lower? Now, if you look in the previous page, we use the letter B for that. Okay, so we could do this a couple of ways. Let's go 70 equals, and I can multiply this by 100 over 180. So I could figure what this is. That's one way of doing it. Another way of doing it would be, since I'm multiplying by 100 here, if I divide this by 100 on both sides, this will actually be gone. And then I get 0.7 is B over 180. And then how do I get B? I'm going to multiply both sides by 180. Okay, so B is 126. So 126 people earn less than John. How many people earn more? Well, there were 180 people, and 126 earn less. Then take away John himself, and you end up with 53 people earn more. All right. Next assignment, if you could do assignment 2 for next class. Thank you.